video, I want to introduce the realKD shell with the most basic use case, which is just running a mining algorithm on some datasets and storing the results. For that, I will use the gold dataset, which I copied into a little demo folder here that consists of 20,000 rows, 14 or 15 attributes and one attribute group. And I want to run subgroup discovery on that. So in order to do that, first of all, I start the shell. So I use the upper left window for that. And I just run the jar file in the folder where I have my import data. Now what I have to do in order to run any algorithm is first I have to import data into what we call the workspace. In order to add stuff to the workspace, we have the add statement in the shell. And I will add a CSV import of the main data file, which is called data au7 and so on .csv. Also, I have to specify the other files and the delimiter. So I say with attributes equal to data and so on underscore attributes .csv. Adding the group files with the option groups equal to, again, a long file name, and here I have the suffix groups. Well, here we go. And what else? Yeah, we have to add CSV, the delimiter. In this case, it is a comma. Finally, for any entity that we add to the workspace, we have to provide an ID under which it is found afterwards. And as an ID, in this case, I just want to use the ID gold table. Okay. Running this statement will take a second or so, and then we see we added the entity gold table to the workspace. It consists of 16 attributes, one attribute group, and 3 derived attributes. First thing that I want to show now here is that if I now exit the shell and re-enter it, first thing that we can observe is that this entity is actually recreated here. I said restored entity gold table. So that is what we refer to as persistent workspaces. And in the file system, we can observe that we now have this jerk file here called goldtable.jerk. This is where the gold table is stored, obviously. Now, in order to run subgroup discovery, which is my main mission here, I also have to add some binary statements to the mix in order to define possible subgroup selectors. For that, we have to add another entity and use another built-in function which is called statements, and this is actually extracting from a standard real value data table a binary propositional logic of binary statements. So I add the statements of the gold table. Again, I have to specify an ID. With the ID statements, or say statements about gold. Oh, why not? Good. So again, another entity has been added. Added entity statements about gold table to the workspace contains 209 propositions. Okay. I don't show it again, but obviously also this entity now is persistent in the workspace and would be reloaded when I restart the shell. Our final thing I want to do is now I want to use these two data artifacts to run subgroup discovery. And for that we have the run statement. So I go through this statement here quickly. So we run a computation which consists of a mining algorithm with some parameter settings. And here I set 2 parameters. The first is the target attributes, and I set it to the value gap. So that is the target attribute for the subgroup discovery. It's the homolumo gap. And the second parameter that is the number of results. How many results do I want to have? And here I just choose 3. That is also in order to be done relatively quickly. And then finally, I specify a second argument of the run command, which is the name of the entity under which the results should be stored. Because that's a new feature. Also, the results will be persistent in the workspace. Now, when I run this, it runs asynchronously, and there is a thread in the background, so I can actually already query here jobs, but it has been already done. And as soon as a job is done, it will be added to the workspace. The results will be added to the workspace under the ID that I specified earlier. So now we have actually a new entity called results, and if I just type results here, we will get the string representation of all the patterns. In this case, there are only 3 patterns that have been found. And this is a bit of an imperfect representation, but you can see that we have actually a descriptor here and some measures, total variation distance of target deviation, and so on and so forth. So that is actually already concluding this very brief introduction. What is perhaps the final important thing is that also the results will now be persistent. So if I restart the shell, you can see that a lot of entities are now restored, and one of them is the results. And I could now go on and investigate those and also perhaps add new results and so on and so forth. Okay, so I hope that was helpful as a little overview, a little flavor of what can be done with the shell. Obviously, most of these things are not yet perfect, but yeah, this is a first introduction, and we can all build on that and go from here to some even more productive space.